right, everyone. We are getting started. Welcome, Tice. So thanks for coming out. Hello, everyone. Welcome to another Tech Bites event. For those of you who are watching for the first time, Spotify Tech Bites is our tech series where we invite both internal and external speakers to join us on stage for a deep dive in a range of tech-related topics. Our goal is to increase knowledge sharing in and out of Spotify. And today we have John Rodriguez talking to us about TypeScript from Assess to Use. We hope you enjoy the talk, and let's welcome John Rodriguez to the stage.
Thanks, Kai. Thanks, everyone, for showing up. This is TypeScript from Assess to Use. So let's begin. For an intro, I've been an engineer here at Spotify for about a year and a half. During that time, TypeScript has started to see a lot of use here, growing from a small-scale experiment to a company-wide recommendation. This talk is about how a lot of other people and I helped make that happen using a tool called the Technology Radar, which I'm going to cover in a little more detail a bit later, to give us a structured framework to guide our adoption and make sure that we were setting ourselves up for success. So let's start by outlining the problem. Why would we want to do this? Like, why would we want to add TypeScript in the first place? So let's start with a little bit of background. When I first joined Spotify, I started on a team that really hadn't been in existence for very long. We had inherited a web application that had originally been intended for a very small, limited purpose, but was in the process of being expanded to cover a lot more use cases. There were only one or two web engineers working on it at this point, and they had no previous experience with static typing or other programming languages besides JavaScript. In addition, the general product direction up until this point has been to treat everything as kind of like an MVP and just iterate quickly. So there hadn't been a ton of effort put into maintainability or testing, since the feeling was that the code might end up getting thrown away or otherwise drastically changed. So now that there seemed to be a little bit more stability on that front and more feature requests coming in, we felt that we should probably try to pay off some of the tech debt that had built up. On top of that, we soon had two other teams with related products that wanted to use our tool as a UI for them as well. Because of prior assumptions that were made when the tool was first created, this wasn't especially easy. So we identified a few things that we needed to improve on. Maintainability was something that we really needed to address right away, because even at this point, we could see that adding a new feature took way more time than it needed to. Making sure that it worked as expected was also pretty hard because of the lack of a comprehensive test suite. It was often hard to understand how a particular part of the code worked because variables were sometimes named in an inconsistent way, and there were lots of cases where assumptions were made. For instance, something would never be null, or it would always be an array, but we had no tests to make sure that those things were always true. Since the code base was now shared between three different teams, sometimes we'd have a situation where the same object was defined 3 times in slightly different ways depending on that team's usage of it. Combined with the lack of comments and appropriate documentation, it was hard to feel confident in our code. Now, of course, we had been trying to address this stuff gradually as we worked on new features, just writing tests and just kind of like trying to clean things up. But we felt that if we didn't take a systematic approach, that things were just not going to get better, very quickly. So one day, all the web engineers from the 3 teams in question met as a group and had a productive discussion about these problems. We decided that maybe adding some kind of static typing to the code base might help us identify and prevent bugs, and also serve as a kind of self-documentation. Since everybody was already using React prop types, which is essentially a way to do runtime type checking, it wasn't really that big of a deal conceptually. It seemed like a good start to addressing the issues that we had identified, so the choice came down to Flow and TypeScript, which are 2 technologies for statically type checking JavaScript. So I had used Flow before, and I had pretty good experiences with it. But TypeScript had a much larger development community, and just more people knew about it compared to Flow. Plus, there was a public roadmap for it where we could see the upcoming changes and prepare for them if need be. So even though Flow's type checking and type inference at the time was a little bit better, we ended up going with TypeScript. So let's step back for a minute. Just to give a brief summary for those who might not be familiar with it, I'm going to quickly explain what TypeScript actually is. So it's a strongly typed superset of JavaScript that compiles to JavaScript. What that means is that valid JavaScript is also valid TypeScript. And for our purposes, it was really just a way to add compile time type checking to our existing JavaScript code. So you can see some sample code here. At a super simple level, we're just kind of telling the type checker what each variable and return type is supposed to be so that it can let us know if we use something in an incorrect way. So it's kind of funny because this particular file had a bug where some downstream code was making some incorrect assumptions about the return types of some of these date functions. It was being treated as a number in one particular case where it actually wasn't. It was like a moment.moment object, which is a JavaScript library for date manipulations. As soon as we started adding type annotations, we got a compiler error. Now that was kind of weird. We're like, what's going on here? But looking at it a little more closely, we realized that it actually was a bug, and we even figured out how to reproduce it. It actually just crashed the entire page. So back to the story. You might ask, surely there must be some guidelines for introducing or using a new technology, right? The short answer at the time was yes, but not really. The official standards specified non-transpiled JavaScript, with JSX being the sole exception, JSX for React. So naturally, it wasn't followed very closely. There is an architecture group at Spotify called TAG, which stands for the Technology Architecture Group, but they didn't really have much front-end representation. So as a result, the guidelines here were not very comprehensive or up-to-date, and there wasn't a very clear process to update them. On top of that, we have a culture of autonomy here at Spotify, so it's kind of understood that as long as members of a squad agreed, it was generally fine to use a non-standard technology within reason. So we just did it. This is a screenshot from the PR where it was added. As you can see, it was done without a lot of fanfare. We started just adding type annotations gradually as we worked on features in the application. Of course, we didn't stop adding tests and things like that just because we were adding types, but having type information definitely helped us feel more confident. We could use it to make sure that we didn't forget a null check somewhere, or to find cases where a variable's name was a little misleading, like if something looked like it should be a string, but maybe it was really an object, and we could fix those cases. We also found a few more bugs like the one I mentioned earlier that had up until this point gone unnoticed just by adding type annotations and noticing that we would get compiler errors in strange places. It wasn't a completely smooth ride, though. I mean, our incremental Webpack builds got a couple of seconds longer, and sometimes the error messages were a little hard to read. That's since kind of improved over time with subsequent versions, but overall, we found that to be a really helpful tool. But eventually, we ran into a little problem. So even though we, as a small group, were all on board, it didn't actually change the fact that we were not adhering to the official standard. Some other non-front-end developers on the team had expressed concerns about productivity being negatively impacted due to having to learn a technology for no good reason. Like they perceived that there was no point to us doing this. And they raised their concerns with tech management, citing the official standards. So what do? So it wasn't official, so we felt that the only thing that we could do was to try and get it accepted as part of the standard technology stack. This was going to be a pretty big undertaking, understatement, right? But we felt confident that we were doing the right thing. We wrote an RFC, request for comments, outlining our general process, as well as some of the advantages that we felt that we had gained by adopting TypeScript, and we circulated it among a small group, our team and some other related teams. Then we presented it to TAG. Unfortunately, they were a little skeptical. This is completely justifiable, of course. To their point of view, this is a pretty big change. Like we're trying to change the way that people write web applications, right? So they asked, why couldn't we just write more tests? Why did we have to introduce an entirely separate language? The general sentiment was that they did not want to have two competing standards, JavaScript and TypeScript. So if we wanted to continue to use TypeScript, we would need to get others on board with replacing JavaScript. We did, however, investigate some rollback strategies, just in case that we were compelled to stop using TypeScript. So like some of the things that we looked at included code mods and things to take the generated output of the TypeScript compiler and reformat it back to JavaScript. So thankfully, we never had to use any of those, but we did check. Around this time, Tag had come out with Spotify's version of the technology radar, which is a tool popularized by a few other companies to help evaluate languages and other technologies in a standard way. It consists of 4 quadrants representing broad categories like frameworks, tools, or languages, organized into 4 rings: hold, assess, trial, and use. Since the release of our version of the Tech Radar happened to coincide with the RFC that we had sent to Tag, TypeScript was listed under assess. So this gave us a framework by which we could continue our evaluation of and experimentation with TypeScript, and a path by which we could hopefully move it into wider adoption. It gave us some legitimacy and a little bit of breathing room so we could continue using it for now. But ultimately, we needed to prove that TypeScript could be a viable replacement for JavaScript. As a consequence of Spotify's culture of autonomy, there really wasn't a history of taking a top-down approach. Like, we couldn't just tell people to use it. So generally, in order to have any kind of like large-scale change, that requires influencing other teams and kind of getting them on board. So let's start actually talking about the Tech Radar. The outermost ring is called hold. What this means is we don't further want to invest in this technology, or we already evaluated it and we don't see it as being beneficial for Spotify. Teams shouldn't use it in new projects, and if they are using it, they should plan on migrating to a supported alternative, like if they're using it for historical reasons or something like that. If the technology in question is broadly, in broad adoption, the Tech Radar should provide a migration path to a supported alternative. Thankfully, we never ended up here. The next ring of the radar is called assess. This technology has the potential to be beneficial for Spotify. Some teams are evaluating it and using it in experimental projects. If you're using it in production, though, it comes with a high cost and risk, mostly due to lack of in-house knowledge, support, and maintenance. But this is where TypeScript started on the radar. So it was now officially an experiment, but we had to start thinking longer term. We didn't actually know this for certain, but it seemed kind of risky to just stay at assess indefinitely, since we might end up getting bumped back to hold at some point in the future if we did that. So we had to figure out how we were going to quantify the benefits and evaluate it so that we'd have a good case for pushing it forward. And we thought a good way to start was just gauging interest from other developers, because obviously, if nobody wanted to use it, then our mission was going to be that much more difficult. At Spotify, there are these things called guilds, which are made up of developers and other interested parties representing a specific discipline, like web, backend, data, quality, etc. We started talking about TypeScript at some of the web guild meetings, just trying to get a sense of what people's feelings about it were, whether they had used it in the past or were even currently using it. Some people had actually used TypeScript or Flow at previous jobs, and it turned out that a few teams were also experimenting with these technologies, although it was definitely a very small number. Plus, the teams who were using TypeScript or Flow hadn't really made a big deal about it or publicized it, so it actually was a very nice surprise to find out that we weren't the only ones trying to do this. As time went on, we continued to keep mentioning TypeScript here and there every few meetings to maintain awareness and make sure that it was still in people's minds. A lot of guild members did express interest, but it was kind of guarded. Like, they hadn't used it before, they were familiar with it, but they had heard good things about it and were still curious. But there was a lot of reluctance to start using it because it was still considered an experimental technology. It's very hard to convince people to spend time and effort adding a new piece of technology to their stack if there's no guarantee that it's going to be supported later on, or if they'll ultimately end up having to remove it. There was also no guarantee that if they did start using TypeScript, that the rest of the company might not at some point end up using Flow or something else entirely instead. Since some of the criteria to move from assess to trial, which is the next stage on the tech radar, is that the technology has been properly evaluated, it would be tough to make the case for this without any indication that other teams actually would do this evaluation. The Spotify Web Unconference was coming up soon, so naturally we figured we would take the chance to bring up TypeScript there too. This slide is the dictionary definition of unconference, so I'm going to explain what that means in a Spotify context. We have one of these every year. It's a place for developers from different offices, so New York, Boston, Stockholm, wherever else we have offices, to meet up, present interesting topics, and just discuss things that might be of interest to engineers in those disciplines. So there's one for web, there's one for backend, there's one for data, et cetera. It's a mix of presentations and breakout sessions, which are informal discussion groups. We voted on a bunch of topics for breakout sessions at this unconference, and there was a lot of interest in discussing static typing. It was probably one of the more well-attended breakout sessions. A lot of people were really interested in the topic, and we did have a really good discussion, but agreeing on the particular technology wasn't that easy. Probably, I'd say most people there preferred TypeScript, but there were definitely a good amount of Flow fans, and some people preferred ReasonML. But at least there was some consensus that static typing in general was a good thing. We worried that if we got too hung up on arguing about the specific technology that was being used, we might lose track of the ultimate goal, which was really to introduce static typing for JavaScript in a standard way across the company. So we created a Slack channel called Web Languages, which was technology agnostic on purpose, so that we could discuss the merits of static typing and the progress of anyone's experimental evaluations without getting too hung up on specifics. So like if one team had a good experience with Flow or another team had a good experience with Reason, we could discuss it in this channel. That being said, TypeScript did seem to be most people's preference overall, so that was good for us. After a couple months of this, it seemed like we really needed to do something else to keep the momentum going. It was still only a pretty small group of people who were using TypeScript, and from discussions with others, it seemed like the lack of official support was a huge obstacle to getting them on board. It's like a classic chicken and egg problem. So without a clear signal from Tag that TypeScript was okay to use, nobody was going to use it. And if nobody was using it, Tag wouldn't give a clear signal that it was okay to use. Because again, keep in mind that their stance was that this should be a replacement for JavaScript if we were going to go down this route. So it seemed that we needed to get TypeScript into trial status before much more adoption could really take place. That brings us to the third ring on the tech radar, which is trial. Technologies in trial have been evaluated for specific use cases. So in our case, this is developing web applications and have shown clear benefits. Some teams might adopt these technologies in production, but generally it's for like low impact projects, not mission critical stuff. They're still not recommended for wider adoption across the company, like maybe there aren't solid guidelines around adoption, or maybe there isn't a migration path, or there isn't good documentation, for instance. So we decided to take a different approach here. Since there weren't very many teams within Spotify that were using TypeScript experimentally that we could use as support for our case, we decided to just use our own experiences in conjunction with statistics and other data that we would gather from the broader development community. So remember, at this point, TypeScript was still in the assess phase. We started talking to a couple more teams that had web engineers, like more web engineers than my team did. There is a web infrastructure team at Spotify that creates internal tools for us that web engineers can use to do things like spin up new projects quickly, easily publish internal NPM packages, or check metrics and logs. And it turns out that they had been using TypeScript internally for a little while, but just hadn't really publicized that fact. But they were definitely on board with what we were doing, and they gave us their full support. Around this time, Create React App, which is a project that allows you to create a React app from scratch with minimal configuration, had also come out with a new version that supported TypeScript right out of the box. So since our internal tooling used Create React App under the hood, what that meant is that we could leverage this for free. With very little work on our part, we could allow web engineers to create new projects that had TypeScript already built in. We also tried to gather more data, like in a more quantifiable form. So we sent out a survey to the WebGuild mailing list that had a couple of questions related to static typing usage, and we assessed the results. So the numbers here are pretty small, right? But they do represent a decent percentage of the WebGuild at that point in time. As you can see, most people weren't using static typing, but it was cool to see that some teams were. TypeScript, thankfully for us, turned out to be the most common technology here in use. We also asked why people weren't using static typing if they responded no to the questions. This was kind of instructive as well, because it basically reinforced what we had learned from prior discussions. Meaning most people were not using static typing because most people were not using static typing, or because it wasn't officially supported. Then we turned to the internet for more support. So according to the State of JavaScript survey in 2018, TypeScript was the second most popular compile to JavaScript technology. The first is just, ES6. That's up from 20% only 2 years earlier. In addition, at the time of the survey, almost half of NPM users had adopted it as well. So interest in TypeScript was growing rapidly by this point, which meant that newer hires could also more reasonably be expected to have a little bit of familiarity with it and maybe even be excited about working with it. So going back to our survey, the fact that nearly 80% of people who answered this question were interested in adopting static typing, along with the other data that we had gathered in support of our experiment, was enough justification for us to take our data and make a case to Tag to move TypeScript into trial. And you can see, after a little bit of discussion, Tag accepted our rationale and officially moved TypeScript into trial status. This is a PR to the tech radar making that official. So now the main barrier to adoption was gone, and it was possible to use TypeScript without worrying too much about whether or not it was actually going to be supported. But how could we actually scale it to the rest of the company and make it so that anyone who wanted to do so could add it to their projects with as little friction as possible? That brings us to the final ring on the tech radar, which is use. This means that this technology is recommended for the majority of teams with a specific use case. So again, our use case was developing web applications. There are guidelines, documentation, and best practices, and it's generally accepted that this is the most effective way to do the task that the technology is being recommended for. So in order to get here, we would need to start coming up with those guidelines and an adoption strategy. By this point, a different team that was responsible for the creator side of Spotify's web properties had started to adopt TypeScript. They were big enough that they needed a standardized set of configurations and project skeletons for various use cases, not just one application like us. So they had created some and opened them up for use by others. Within the WebGuild, we thought that these configs and project skeletons might be usable as a base for company-wide use, since they'd already proven themselves to be pretty helpful in scaling TypeScript to a larger team. On top of that, we created another Slack channel, TypeScript, where anyone could ask questions and get help with project setup, type annotations, or any other related issues. The intention was to use that, among other things, to make it easy for anyone in the company to solve problems that they might be having when first adopting TypeScript. One of the issues that we encountered was that there are multiple ways to do a lot of common tasks. For example, you could use Babel and Webpack to compile a TypeScript application, or you could just use TSC, which is the TypeScript compiler, all by itself. There were two competing linters to enforce code style guidelines and find potential bugs. TSLint, which is a TypeScript-only linter, and ESLint, which is a JavaScript linter that has plugins that allow it to be used with TypeScript. Libraries can also have separate type declarations. This allows consumers to take advantage of the type information in their applications. It's possible to do this either by publishing the declarations with the library or by publishing them as a separate package. To address these problems and help develop some guidelines, we formed a small working group with the intention of producing a set of recommendations and adoption paths for people to migrate their JavaScript applications to TypeScript. So once we got in a room and started talking about this, we came up with some decisions pretty easily after a couple of sessions. Just in the interest of reducing friction, we just decided to use the Create React App defaults for apps. So Babel and Webpack for transpilation, and TSC, the TypeScript compiler for type checking. For libraries, we just decided to use TSC without Babel, since that seemed to be the easiest approach. But we did provide some instructions and configs for existing projects so that maintainers could add TypeScript to those if they wanted to. Our choice of a linting technology was actually made easier by the fact that plans to deprecate TS-lint had just recently been announced. So combined with that, ES-lint equivalents to all of our TS-lint rules already existed, so that really wasn't too big of a deal. And for publishing type declarations, we just decided to publish them with the library unless there was a good reason not to. For instance, if the library was still written in plain JavaScript, but consumers of that library wanted access to type declarations. So to get more teams on board, we started to do a little bit more knowledge sharing. By this time, a decent number of developers were already using TypeScript, but we did a lunch and learn to introduce some basic concepts to people that might have been unfamiliar with it. And there was a blog post that was written that was circulated among R&D to kind of like raise awareness and just generally let people know what we had done. Also, as part of the output of the TypeScript working group, we created some common NPM packages with our recommended configs. These were modeled after React scripts, which is part of Create React App and provides a reasonable default configuration for a project so that the end user doesn't have to manage these settings themselves. We also wrote a bunch of documentation outlining common migration paths and strategies and made sure that it was easily available to anyone who was interested. And then on top of that, we also continued to use the TypeScript channel as a way to help others in the company with their TypeScript problems. A few months later, we had another unconference, but this time it was for all engineers at Spotify, so it was renamed to SPEC, the Spotify Engineering Conference. We had a couple of talks related to TypeScript this time, and there was a workshop that was pretty well attended. Finally, we felt that we had a critical mass of users. By this point, adoption was pretty painless, since there were common libraries, configs, and guidelines. Anyone who had problems could easily ask questions and hopefully get answers. So we opened another PR to the Tech Radar requesting to move TypeScript to use, and it was accepted. From now on, if a team wants to create a web application at Spotify, they should write it in TypeScript. We released our configs as open source. They have our recommendations for ESLint, TypeScript, and Prettier. You can get them at github/spotify/webscripts. So to summarize, this started off as something pretty small scale, intended to be just another way for one team to help write better code. When we first started to try out TypeScript, we definitely did not do it with the explicit intention of changing the entire company's recommended technology for developing web applications. But through lots of discussions with teammates and with others in the organization, we learned that this was something that could be more broadly useful. Once there was a structured way in place to introduce potential changes, it became a matter of gathering data, spreading awareness, and following the steps. Some of the things that we learned from this experience are, that first, it's very important to get a rough consensus before you start doing something like this. Our initial RFC was super helpful in putting TypeScript on the radar, both metaphorically and literally, and gave us a foundation for everything else that we did. There are always going to be both early adopters and tail-end adopters who won't use something until just about everyone else is using it. So you're never going to get everyone to 100% agree on something like this. But it's very important just to make sure that you do provide an opportunity to give everyone a chance to raise any concerns and make sure that those concerns are addressed in a reasonable way. Ultimately, it's more important just to make sure that nobody strongly disagrees than it is to make sure that everybody agrees. Secondly, since TypeScript is essentially JavaScript with types, it wasn't as big of a change as having to learn a completely new language like ReasonML. Next, the tech radar gave us a way to explicitly communicate our intent, to frame what we were doing in clear terms and with a defined goal in mind. At any point in time, everybody understood what the status was, how TypeScript was currently being used, and what we needed to do to get to the next step. Along with this, the more friction that we were able to remove from the process, the more likely it became that people would adopt a new technology. And finally, it's pretty important to stand behind a cause that you believe in. If you think what you're doing can be a net benefit, then it's definitely possible to make a change if you can get others on your side. In our case, there were a lot of people who were already interested, but nobody had really stepped up and tried to rally everyone together. The flip side of this, though, is that you're definitely going to end up doing a lot of work, but the results can be worth it. Thanks.